Well, hello, Math 126 fans. Several students are asking me questions about this fall 2022 final. So I'm just going to do a couple parts of it that people are asking about. The first question here is about planes and lines and angles between them. So just a quick review. The angle between two vectors, I call this the 10-star fact, can be found provided you can find two vectors that are tail to tail. I'm going to make this a little smaller so we can see it. So we're trying to fill that in. When we say the angle between two planes, it's the angle between their normals. The normal of we talked a bit why that would be, but the normal of the first plane is 8, -4, 1. The normal of the second plane, that might be confusing for some because it's just the plane x equals 4. But when it's like that, you can think of it as if there's a 0 next to the y and a 0 next to the z. And so the normal is 1, 0, 0. So this is a direct kind of vector operation thing back when we were doing angles between vectors. So you just compute. So maybe I won't say too much here, but you would do the dot product, which is 8. You would divide by the lengths. The length of the second vector is 1. The length of the first vector is not necessarily nice. 64 plus 16 plus 1. So you would do arc cosine of that. The directions don't say if it needs to be in radians or degrees. So they must have accepted either one. I think on our test, I would say rounded to the nearest degree or something. Write parametric equations for the line of intersection of this plane and this plane. Okay, so you would write those down. So you have one plane, which is 8x minus 4y plus z is 3. And this other plane, which is y equals 0. So the strategy in these ones was you are trying to find a point and a direction. So some of this just looked funny because there are horizontal and vertical planes, but that actually makes some of it easier. We had a few different strategies for this. One strategy was to find 2 points and then use those 2 points to give the equation of the line. You put 1 point here. You subtract to get a direction vector. That's one good strategy for finding the equation of a line. The other was to do the cross product of the normals, and that's another way to get this. And some students like that because they saw that in the book, and so both are perfectly fine. No matter what, you have to find 1 point. And the way we find a point is we combine. Now these combine pretty nicely because you get 8x plus z equals 3 when you combine. And your job was to find any numbers that worked in there. So for example, if x is 0, then z has to be 3 and y has to be. So there's an example of a point, 0, 0, 3. Is that the only point? No, there's lots of others. So you could, if you wanted to just finish the problem by finding a second point, you could find a second point. Just pick anything you want. Now, if you want whole numbers, you might have to think harder. If you don't care about whole numbers, you could just pick z to be 0, in which case x is 3/8. Yeah, that's kind of bad, but you would have 3/8 and y is 0, 0. This is 1 point. And I already found this point 0, 0, 3. If I find a vector between those, it will be a vector in the direction of the line. So let's just do that. 3/8 minus, so I'm just going to put a 3/8 here. 0 minus 0, 0 minus 3, so -3. So that's one equation for this. Now you could rescale that vector, like multiply both by 8. So there's a whole bunch of correct answers. Find the point on the plane that is closest to this point, 26, -7, 10. This particular one, we have more than one way to do it. There actually was a formula way back in 12.5 that you saw a couple times in the homework that would immediately give you that answer. So you could look back in 12.5 and say, okay, I'm going to add that to my note sheet. There's a few other things you can do. You could do a minimum distance problem, meaning I want to find something that is closest to 26. So I think I'm going to leave students to sort of review for this piece. Now, I don't really like this method because the next step is to substitute. Maybe it's all right. Substitute the z or the x or the y, take derivatives, and see what you get. There's even a third sort of geometric approach, which is I have the equation of a plane. I have a point out here, 26, -7. I would like to go walk and find the point that's closest. Well, I actually can find the equation of that line essentially without much work at all because I have the equation of the plane. So I can think, so I'm basically giving a third option here. So one is to use the formula from 12.5. One is to do a minimum distance. And another one is to find the equation of that line. Now the equation of that line is actually really fast to find because you know the point and you can use the same vector because it points in the same direction as the normal. So you can use this 8 and -7. And z is 10 plus t. And you could find the intersection of these two things. In finding the intersection of those two things, you will find this point. And once you have those 2 points, you can use the regular old distance formula. So I think I'll just stop there on that one. But a student was asking about that question, so I thought I would quickly do it here.